In this question, we are asked to find the size of angle x, and they said point O is the center of the circle. So how can we find x here? We are given the sizes of three angles, 40 degree, 25 degree, and 24 degree. And we are expected to find the size of angle x from them. Let's start through triangle ABC and see what we can get from it. In triangle ABC here, two of its angles are known, but the third one is unknown. So we can label the unknown angle B and form an equation. Since the sum of angles in a triangle is equal to 180 degree, 40 degree plus 25 degree plus B will be equal to 180 degree. 40 plus 25 is 65, so this will be 65 degree plus B equal to 180 degree. To find the value of B, we subtract 65 degree from both sides. So we are going to have 65 plus B minus 65 is equal to 180 minus 65. 65 minus 65 is 0, so we forget about it. B is now equal to 180 degree minus 65 degree is 115 degree. So B is equal to 115 degree. And that means this angle here is 115 degrees. Since it was one, we labeled angle B. So we can go ahead and replace B with 115 degree. Now if you look at this angle here, this angle is an exterior angle of this triangle ACD. And in geometry, the exterior angle of a triangle is equal to the sum of the two interior angles that are opposite to each. And that means the sum of this angle and this angle must be equal to this angle, which is 115. So we can label this angle P and this one Q and form an equation. X plus P plus Q plus 24 degree is equal to 115. Because this angle here is X and P, while this one is 24 and Q. That is, hope you understand. But what are the sizes of angle P and angle Q? If you look, since both line AO and line OD are both radiuses of the circle, that means line AO is equal to line OD, because the radius of a circle at all points is equal. And hence, triangle ADO is an isosceles triangle, meaning angle P here is equal to angle Q. So to find the size of angle P and angle Q, we need the size of this angle here. If you look at this angle and this angle, you will notice that both are formed from the same arc, one to the center of the circle and the other to the circumference of the circle. Recall, in a circle, if any two angles are formed from the same arc, one to the center and the other to the circumference, the size of the angle formed at the center is twice the size of the angle formed at the circumference. So that means if this angle here is y, this must be equal to 2y. Or let's write it there. But what is the value of angle y? Let's come back here. Since this angle here is 115 degree and is on the same straight line with angle y, that means 115 plus y is equal to 180 degree, because the sum of angles on a straight line is equal to 180 degree. So to find the value of y now, we subtract 115 from both sides. So y is now going to be equal to 180 degree minus 115 degree, which is equal to 65 degree. Since the value of y is equal to 65 degree and the size of this angle is equal to 2y, this angle will be equal to 2 times 65, which is equal to 130. Now we got this angle here to be 130. Coming back to this triangle as a whole, since this angle is 130, to find the values of P and Q, we subtract 130 from 180. Now 180 degree minus 130 is 50 degree. So therefore P plus Q is equal to 50 degree. But recall P is equal to Q. So therefore P is equal to 50 degree over 2 and Q is equal to 50 degree divided by 2. Here there's 25 degree and this also 25 degree. Now come back to this our earlier equation here. X plus P plus Q plus 24 equal to 115. Substituting the respective values of P and Q, we're going to have x plus 25 degree plus 25 degree plus 24 degree equal to 115. 25 plus 25 plus 24 is equal to 74. So we're going to have x plus 74 is equal to 115. To find the value of x here, we subtract both sides by 74 degree. So this will be equal to x plus 74 minus 74 equal to 115 minus 74. 74 minus 74 is 0. 115 minus 74 is 41. So x equal to 41. Therefore, this angle here, angle x, is 41 degree. Here, PQRS is a rectangle. This line PR here, 8 centimeters. Line QR here, 21.6 centimeters. And they said line AB bisects line QR, meaning it divides line QR into two equal halves. And hence, this line equal to 21.6 divided by 2, which is 10.8, and this also 21.6 divided by 2, also 10.8. And line BR is 3 times the length of line BS here, so you can label this X. So if this is X, this line BR must be equal to 3X, based on the information given here. We are asked to find the length of this line AB here and line BQ. So where should we start from? We can start from anywhere because this is a very simple question. So I think we should start from line BQ. Let's find the length of line BQ. So from this triangle here, we can find the length of line BQ if we have the length of the two other sides and the interior angle triangle. And we know that in a rectangle, opposite sides are parallel and equal in length. So this line QS here, you can see is opposite to this line PR here, and hence also equals to 8 centimeters as well. Another thing to be noted is that in a rectangle, non-parallel sides are always perpendicular to each other. And that implies that this here is a right angle. This, and this are also two right angles. So now here, this is a right angle triangle. So since this is a right angle triangle, we can use the Pythagorean theorem to find the length of line BQ if we have the length of this line BS here. So what's the length of line BS? We have this as x and this line BR as 3x. So if we have the length of line RS, we can substitute it and find the length of line BS. So if you look closely, this triangle here, also triangle QRS, is also a right angle triangle on its own, because this angle here is a right angle. So using the Pythagorean theorem states in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the two other sides. So now this line QR here is the hypotenuse because it's facing the right angle. So we can go ahead and substitute 21.6 all squared equal to 8 squared plus line RS squared. Making line RS the subject of the formula, line RS equal to square root of 21.6 squared minus 8 squared. 21.6 squared is 466.56. 8 squared is 64. 466.56 minus 64 is 402.56. Square root of 402.56 is 20.0639. 0.639 is a very negligible value, so we can approximate it to be equal to 20. So line RS is equal to 20 centimeters. So if line RS is 20 centimeters, this line PQ here must also be 20 centimeters because of the earlier property of angle we mentioned. Now let's come back here, because our main reason for finding the length of line RS is to find the length of line BS. So if you look here, since this line BS and line BR make up line RS, you can say line RS equal to line BR plus line BS. Line RS is 20 centimeters, BR is 3x, and line BS is x. So now 20 equal to 3x plus x. 3x plus x is 4x. So now 4x equal to 20. To find x, we divide both sides by 4. So now 4x over 4 equal to 20 over 4. Here 4 cancels 4, and here 20 over 4 is 5. So now x equal to 5. So come back here. Substituting x equal to 5 here, this will be 5 centimeters. This here, 3x will be equal to 3 times 5, which equals to 15 centimeters. So we'll find the values. Coming back to line BQ here, to find its length from this triangle here, we can use the Pythagorean theorem which we just mentioned earlier. So here, this line BQ is the hypotenuse because it's facing the right angle. So now, line BQ square equal to 8 square plus 5 square. The exact value of line BQ will be equal to square root of 8 square plus 5 square. 8 square is 64. 5 square is 25. So now 64 plus 25 equals to 89. Square root of 89 is 9.4339, which approximately equal to 9.4. So line BQ here is 9.4 centimeters. We found the length of line BQ. Now we are done with line BQ. So let's come back to line AB. How can we find the length of line AB? Okay, right now I don't know if you can see what I'm seeing here, because here I'm seeing two ways we can follow to find the length of line AB. The first way, which is from this triangle here, triangle ABQ, we can find the length of line AB because we have the length of the two other sides of the triangle. But that would mean that we have to find the sizes of these angles here, and that would take a lot of time. So I think we should try the other alternative. Now, recall line AB is a bisector of this line QR here. So that means this here is the midpoint of line QR. So if you look also, line QR is a diagonal of the rectangle because it was drawn from this point here down to this point. And I believe we all know that the midpoint of a diagonal of a rectangle is also the midpoint of that rectangle. And that means this here is the midpoint of the rectangle PQRS. So if this is the midpoint, that will mean the distance from this point to this point here is exactly half the distance from here to here. So the distance from here to here is already given here to be 8 centimeters. So you can draw another line here parallel to this line PR here, representing the distance from this point to this line here. So this angle here is a right angle because this also here is a right angle. So now we are having a right angle triangle here with line AB as the hypotenuse because it's facing the right angle. We already noted that the length of this line here is exactly half the length of this line PR here. And we have line PR to be equal to 8 centimeters. So this would be 8 centimeters divided by 2, which equals to 4 centimeters. So to find the length of line AB here, using the Pythagorean theorem, we still need the length of this side of the triangle here. So what's its length? Coming back here, since this is the midpoint of the rectangle, this point is also the midpoint of line RS. And recall, line RS equals 20 centimeters. So the distance from this point to this here must be 20 centimeters divided by 2, which equals to 10 centimeters. And here, this is 5 centimeters. So this must be 10 centimeters minus 5 centimeters, which equals to 5 centimeters. So now, from this triangle here, we have this to be 4 centimeters and this 5 centimeters. And here, line AB is the hypotenuse of the triangle. So, using the Pythagorean theorem, We already stated it earlier, but let's restate it again. The Pythagorean theorem states that the square of the hypotenuse of a right angled triangle is equal to the sum of the squares of the two other sides. So now, line AB squared equal to 4 square plus 5 square. 4 square is 16 and 5 square is 25. Here 16 plus 25 is 41. So line AB squared equal to 41. So now, to find the exact value of line AB, we find the square root of both sides. So square root of line AB squared equal to square root of 41. Here, square cancels square root, and here, square root of 41, press your calculator, is 6.4031. So line AB equal to 6.4031, which approximately equal to 6.4. So line AB equal to 6.4 centimeters. So we found line PQ to be equal to 9.4 centimeters and line AB to be equal to 6.4 centimeters.